Question 2.
Y equals 4x over x squared plus 5. Part A of the question asks us to find dy dx, writing your answer as a single fraction in its simplest form. So we can write this fraction as u over v. Comparing the numerators and denominators, we can see that u equals 4x and the v equals x squared plus 5. Differentiating 4x gives us du dx equals 4, and differentiating x squared plus 5 gives us dv dx equals 2x. Remembering the quotient rule, we know that dy dx is equal to v du dx minus u dv dx all over v squared. Now to get the final answer for part A, we just need to substitute these values into the quotient rule. So we have v, which is x squared plus 5, times du dx, which is 4, take away u, which is 4x, times dv dx, which is 2x. And this is all over v squared. V is x squared plus 5, so v squared will be this squared. Expanding the numerator gives us 4x squared plus 20 minus 8x squared. We leave the denominator as it is, as this is in a simpler form than if we were to expand it. All that's left is 4x squared minus 8x squared, which gives us minus 4x squared over x squared plus 5 squared. For part B, the question says, hence find the set of values of x for which dy dx is less than 0. We've just found out that dy dx is equal to 20 minus 4x squared over x squared plus 5 squared. We are asked to solve dy dx is less than 0. So we need to solve the inequality 20 minus 4x squared over x squared plus 5 squared is less than 0. Cross multiplying, we have 20 minus 4x squared is less than 0, because this times 0 is 0. Dividing everything by 4, we get 5 minus x squared is less than 0. So x equals plus or minus root 5. These are what's known as your critical values. They're not your final solutions. These are your critical values. For the final part, I always prefer to draw a quick sketch of what the graph y equals 20 minus 4x squared would look like. So roughly it would look like that, crossing at plus root 5 and minus root 5 on the x-axis. We're interested in all the values that are less than 0, so everything that's below the axes. And so this is the region x is greater than root 5 and x is less than minus root 5, so everything on this side and this side.